Okay, we are in lesson 2 in module 7 of McGraw-Hill on page 393. Angle relationships and triangles. Okay, a line segment is a part of a line containing two endpoints and all of the points between them. So if you're talking about a line segment, it's from here to here. Okay, a triangle is formed by three line segments that intersect at their endpoints. So a triangle. Then the points where they, love the updates. A point where the segments intersect is a vertex. So this right here is a vertex. This right here is a vertex. This right here is a vertex. They're all points. The three angles that lie inside the triangle formed by the segments and the vertices are called interior angles. So this angle, and this angle are called interior angles. Now, if we look at this first one right here, the side of this side right here, from that endpoint to that endpoint, that line segment is named by, you got to have the line segment on top, XY. Then this one over here, this part right here, it's the line segment. Now, I should go back to this. It could also be named YX. Usually I do alphabetically, but it can be either way. This one right here can either be YZ, I like alphabetically, or it could have been ZY. This one over here, the one that goes this direction, would be XZ. Again, I like alphabetical. So when you are naming the sides, you put the line segment on top. Okay? Anytime that you're naming them, you put the line segment on top. Okay, now, the vertex. This one right here is the vertex X. The one highlighted is the vertex Y. And this one is Z. Okay? Now, this is angle X. Now, I also want to say that there is another way that you can name this angle. You can actually name it by using three letters. Y, X, Z, where the vertex is in the middle. Now, could you have also done Z, X, Y? Yes, as long as the vertex is in the middle. Over on this one, this would be angle Y. Now again, as long as you have the Y in the middle, you can say X, Y, Z. The vertex is in the middle. Or you could have had Z, Y, X with the vertex in the middle. Last but certainly not least, you have angle Z. Or again, you can write it as X, Z, Y as long as the vertex is in the middle, or Y, Z, X. Now, okay, so let's talk about that for just a second. Sometimes people are like, well, why do I have to do the three letters? If you have just a plain old triangle like the ones we've been given with no other parts to them, then you can use the single letter. But if for some reason all of a sudden they draw this over here and there's a right here, you have to use the three letters. So as long as there's not something like that, you can just use the one letter. Now, we're not actually going to do this, but we're going to talk about it. So, if I was to take a triangle and I was to cut off the 3 angles, and I would put, oh, seriously. If I put these sides right next to each other, should do it with a dark, you know what, let me do it like this. No, I'm not. I'm just going to leave it like it was. If I put those next to each other, like so, they make a straight line. What is the measure of a straight line? What is the measure of this right here? Well, it's half of a circle. So half of a circle is 180 degrees. So all of the angles inside the triangle equal 180 degrees. So let's look at this. I'm going to take 110 and 25 and 45, 110, 25, 45. This becomes 10, 2, 4, that's 8, 1. It becomes 180 degrees. So, here it is right here. The sum of the measure of the interior angles of a triangle is 180 degrees. So what it's saying is the 3 angles inside, when you add them up, you will get 180 degrees. Okay, so if I'm looking at this right here, let's remember that this angle right here, when it has that, is 90 degrees automatically. So we've been given 90 degrees and we've been given 56 degrees. So if I add those 3 up, x, 56, and 90, it should equal 180 degrees. So if I add that together, I get 146. I subtract 146 from both sides, and I get that x is 34 degrees. Okay, so here I have 3 angles. I have x, I have 47, I have 86, and that should equal 180. So I combine like terms, so that's a 3, right? Yeah. That's going to be 12, 13, 133 is equal to 180. I subtract 133 from both sides, and I get x equals, that's a 7, 47 degrees. So this angle right here is 47 degrees. Cute little puppy. Okay. In the triangle ABC, the measures of the angles A, B, C respectively are in a ratio of 1, 4, 5. Okay. So 1, 4, 5, when we add these up, are going to equal 180. Okay, it's a ratio. So that means it's going to be 1x, 4x, 5x. When you add all of those up together, it's going to equal 180. So that would be 10x equals 180. Divide by 10 on both sides, and I get x equals 18. So 18, and then I take 4 and I multiply it by 18, and I get 72. And then I take 5 and I multiply it by 18, and I get 90. Okay? Oh, they did all this down here. So I do the same thing here. I have 1, I have 2, I have 5. And when you add them together, it should be 180. So 8x equals 180. I divide by 8 on both sides. And x equals 180 divided by 8, 22.5. So I have 22.5. I have, should say 1x equals that. 2x equals 45. And 5x equals 112.2 or 112.5 degrees. Okay. Now we have exterior angles. Okay. These three right here, those were interior angles because they're on the inside. Now we're going to be talking about exterior angles. And exterior means it's on the outside of the triangle. So, in addition to its three interior angles, a triangle can have an exterior angle formed by one side of the triangle and an extension of the adjacent side. So let's look over here. So they extended this. So 5 is exterior. They extended this. So 6 is an exterior. They extended this. So 4 is an exterior. Okay? So in the diagram shown, angles 4, 5, and 6 are exterior angles. An exterior angle is supplementary. Okay? They're supplementary. So supplementary, if you remember, really? Means that the sum of two angles is 180 degrees. So that means these, I'm going to do these two colors. These two angles added together are going to get 180. Then these two angles added together are going to get 180. And then these two angles, let's do a different color. Orange. How about these two? 3 and 5 would be 180 degrees. Okay? Each exterior angle of the triangle has two remote interior angles that are not adjacent. Super important that we get this word right here. Not adjacent. Adjacent meaning next to. Okay, so if I look at angle 5 right here, this is exterior. 3 is touching it, so it's not this one. So the only two that are interior that are left that are not touching it are these two angles, angle 1 and angle 2. Okay? So let's do it for a different one. Okay, angle 6. We're talking about this angle right here. Angle 2 is adjacent to it, so it's that is not a remote interior angle. These two right here are the two angles that are the interior angles. So 1 and 3 are the remote interior angles. Okay. So okay, the remote interior angles. So we're going to talk about this. So it says angle sum of a triangle. So that means you add these three numbers together. So 60 plus 55 plus 65 is going to get 180. Okay. Then 65 plus 110 or 115. These two, those are supplementary angles. They are linear pair, they are supplementary angles, so they equal 180. So since these two equal the same amount, we're going to set them equal to each other. So this part right here is right here. This part right here is on this side. And if you notice, there's a 65 on both sides of the equal sign. And because there are 65 on both sides of the equal sign, we're going to subtract those. When we do that, I'm left with 60 plus 55 equals 115. Now let's look at those numbers. Okay, I'm going to hit this. I'm going to hit. Okay. I'm actually going to use this color. So 60 is right here. 55 is right here. And 115 is right here. So we're going to actually do this. So the exterior angle is equal to the sum of the remote interior angles. Okay, these were the remote interior angles, and they equal 115. Okay, so the measure of the exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. Okay, so this is my exterior angle right here. It's equal to the measure of these two angles. Okay, so here we go. So this is my exterior angle. So my exterior angle equals the sum of my remote interior angles. So the measure of angle 2 plus the measure of angle 3. The measure of angle 1 equals, well, angle 2, it says right here is 55. Angle 3 is 60. So the measure of angle 1 is going to be 115 degrees. Okay, so this one. Now some of you are like, oh, that's too much stuff. I can't see it. Okay, so rewrite it. Okay, so I have my bottom, I have my up, I have my down. Okay, it's not perfect, but 1, 2, and 3. So the measure of my exterior angle, which is 1, is equal to the sum of my two remote interior angles. Okay, so it says that 2 is 25 degrees, 3 is 45 degrees. So the measure of angle 1 is going to be 70 degrees. Okay. We're finding the measure of angle 2 and angle 1. We know that this angle right here is 135 degrees. We know that this is 90 degrees. Okay? So let's do this. We're going to redraw this so it's easier for you to see. Okay, this is 135, this is 90, and this is angle 2. So the measure of angle 4 equals the measure of angle K plus the measure of angle 2. The measure of angle 4 we know is 135. The measure of angle K right here we know is 90 degrees. So now we need to find the measure of angle 2. So we're going to subtract 90 from both sides. When we do that, we get 45 degrees is equal to the measure of angle 2. So this is 45 degrees. Okay? Then it wants us to find the measure of angle 1. So if I look at this in a different color, if I look at this, this is 135. This is the measure of angle, or this is 1. That is a linear pair, so it's supplementary. So the measure of angle 1 plus 135 is going to equal 180 degrees. So I subtract 135 from both sides, and the measure of angle 1 is 45 degrees. Okay, so we're going to do the same thing right here. Okay, this time this is 147 degrees. And we're going to find angles 1 and 2. Okay, we're going to find those two. So I'm going to just start off with this one right here. So this is 147 degrees. This is angle 2. That's supplementary. It's a linear pair. So the measure of angle 2 plus 147 equals 180 degrees. So I'm going to subtract 147 from both sides. I'm going to get the measure of angle 2. That's a 33 degrees. So this is 33 degrees. Then the measure of angle 5. I'll even redraw it for you. Okay. So this is angle 5, which is 147. This is that's not a right angle, but oops. And this is angle 1. So the measure of angle 5 plus the measure of, angle 5, the measure of angle 5 equals the measure of angle K plus the measure of angle 1. We know the measure of angle 5 is 147. We know the measure of angle K is 90, and we're looking for the measure of angle 1. So I'm going to subtract 90 from both sides, and that's going to get me 57 degrees as the measure of angle 1. Okay. So here we've got it. What are the measurements of CDE? So CDE is going to be this, I'm going to highlight this ring right here. Remember, this right here is the vertex. And BCE. BCE. So it wants this angle that's right here. So those are the two things we're looking for. So there are a couple of ways that we can look at it. If I want to find this right here, I don't want to do that. If I'm going to go for this angle that's right here, let's rewrite it for a second so that you can see the okay. So this is 42 degrees. This is 3x minus 21 degrees. And this is 2x minus 21 degrees. This is an exterior angle. So 3x minus 21 equals, these are two remote interior angles. So 2x minus 21 plus 42 So 3x minus 21 equals 2x plus 21. Subtract 2x from both sides. Get x minus 21 equals 21. Add 21. Get x equals 42 degrees. So the x value is 42. So I want to find 3x minus 21. So I'm going to replace the x with 42. That's going to give me a 6, 126 minus 21. So 105 degrees. So this angle right here is 105 degrees. Okay? Then, this right here, how do I want to draw this one? Let me come over here. Maybe a different color. So now if I'm doing this one, this is the exterior angle. This is the remote interior angles. Okay? Well, we just found that this is 105 degrees. So 105 degrees is equal to 2y plus 3y. So 105 degrees is equal to 5y. Divide by 5. And I get 21 is equal to y. Okay? So we're trying to find the measure of angle D, which is 3y. So the measure of angle D is equal to 3 times 21, which would equal 63 degrees. Okay. Now I could have done it other ways also, but I went with that. Okay. So first I want to find, never mind. So right here, this right here is an exterior angle. These are two remote interior angles. So 2x plus 3x equals 110. 5x equals 110. Divide by 5. Get x equals, goes in 22 times. 22. So this angle would be 44 degrees. This angle would be 66 degrees. Now, you could, without doing any other work, there's something that I should have shown you on the other one, but I didn't. I'm going to show you on this one. These are parallel lines. This right here, this angle, and this angle would be congruent to each other because they are alternate interior angles. So what I could do is just say, well, since this is 44 degrees, that makes this also 44 degrees. So it wants the measure of angle FDE. So I need FDE. FDE is right here. Well, that was 44 degrees. And then it wants, the measure of angle DEF. Okay, DEF. DEF is that one. So that was 66 degrees. And then the measure of FHG. And that was this one right here, and that is also 44 degrees.